the pain and suffering begin of greatest common factor. But before that, I actually think I forgot to put the pause symbol in. So I'm going to tell you to pause, even though you might not see it, to go on to the rest of the presentation. But the pain and suffering, the students will be able to find greatest common factor. Everyone hates greatest common factor and least common multiple. I hear that all the time. Oh, I don't understand. Okay, I'm going to make it nice and easy. I'm going to teach you 2 different ways today. Greatest common factor, or people say, what's the GCF? This will be done through presentation and classroom activity. You're doing the presentation tomorrow. You're doing the presentation tomorrow. No, clearly you're doing the presentation right now. Classroom activity is going to be done tomorrow. So don't think about it as evil. I'm going to give you a few different ways to do it. First, greatest common factor. How am I going to use this in life? Please don't ask me that question. I'm like too retired right now. I have a baby at home, everything else, to think greatest common factor and where every single one of you guys can do it. So why do I need to know this? Best way I can say is reducing. How are you going to use it in life? You're probably going to use it. I'll think of something later. I'll tell you guys in class. Some wonderful teacher excuse. But why am I going to need, why? Well, because it's reducing. Well, first, way 1. You can use it for reducing later is what I meant to say. So 30 and 45. I want you to find the greatest common factor between them. So first, we need to list all the factors. That's the first thing you want to do. If you do it this way, it's actually pretty easy. You can use a multiplication table. So we have 1, 2, 3, 5, 10, 15, 30, because 1 and 30 are always factors. If you don't know factor, watch the last video. It's like 2 videos ago, I think, or maybe it's the last video. I don't know. Just watch it. 45 is 1, 3, 5, 9, 15, 45. Those are all the factors of 45. So if you write down all the factors first, this becomes pretty easy. Because what we're going to do is, since we have all the factors, just highlight the ones in common. So 3, 5. 5 is going to come up in a minute because we see there's 3 on both of those. There's 5. Where are you? 5. There's 5. So they do have 1 in common. I should have probably highlighted 1. Sorry, I didn't highlight 1, you guys. And 15. So the greatest common factor for this would be 15 because that's the highest number between all the factors of 30 and all the factors of 45 that they have in common. That's all it is. So if that way's kind of hard, I'll show you another way, way 2. So way 2 in a second, you're going to find out in a second. La-di-da-di-da-di-da-di-da. Where is it? Way 2. Come on, way 2. I'm going to show you factoring. It's the factor tree method. So the factor tree method for 30 and 45, exact same one. So I'm going to show you can get the exact same answer doing it this way. Factor tree, come on, where I can scream? Also known as prime factorization. So AKA prime factorization factor tree. So you might already know this. But before we start it, you're going to use prime numbers. 2, 3, 5, 7, 11. They're all the prime numbers. Start low, so start with the low numbers and work your way up. And I'm going to show you what I mean by that in a second. Skip to the next slide. I'll say 2 and 15. So 30, we can divide by 2. It makes 15. You can use divisibility rules. So 2 times 15 equals 30. So now, since 2 is prime, we're done with 2. Let's go to 15. 15 is 5 times 3. That's it. We have all prime numbers. We're done. Okay, so 3 goes at 3 and 15 right over there. So again, 3 is prime, so we're done with it. 15, we're going to break down into 3 times 5. So again, we're done. We've broken those all to prime numbers. Well, Mr. Beuthin, what am I going to do with all this stuff? Okay, well, they both have a 3 in common with their prime numbers. They also both have a 5 in common, which is going to come up in a second. So let's circle the numbers they have in common. They have 3 and 5. So 3 times 5 is 15. If that doesn't make sense, I'm going to do one more for you guys, and you're welcome to use either method you want because 15 is the answer for 33 and 45 is 15. But you're going to find out with really, really big numbers, it's probably better to use this method. So try your hardest this time to kind of take notes and listen. So 48 would be 2 and 24. Okay, so 2 times 24 is 48. So we're done with the 2. Now 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So we broke that all into prime numbers. So 2 times 2 times 2 times 3, 2 times 3 would be 48. So this next one, 2 times 36. Okay, so it's also 36 is 2 times 18. That's why I said start low, do 2's first, and then we have 18 is 2 times 9, and last is 9 is 3 times 3. So those are all the prime numbers for all of them. So we just did prime numbers, start low, and work up. They have a 3 in common, so let's circle those 3's. Next, they have a 2 in common. So I'm not going to put on the same wavelength over there, but you're going to see where I'm going to circle 1, 2, and I'll circle the other 2. So we have a 2 in common over there. And then we have another 2 in common going up the little tree. Where are you? There's the 2. And then we have one last 2 in common. So the last 2 is going to be circled. Those are the numbers both of them have in common. We circled them. Yeah, 48 has an extra 2 and 72 has an extra 3. We don't need those, just what they have in common. See, there's the ones we circled. So 2 times 2 times 2 times 3, trust my math, is 24. They have a 24 in common between both of them. So the greatest common factor of 48 and 72 is 24. So that's it. You can use either way. On the test, we're not going to go the higher level math. You'll need all that. Like, what's the greatest common factor? 3,600,000. No, we're just going to do low numbers like this. You'll see stuff like this on the test. Right now, if you need to pause and go back, take notes, pause, go back, because this is kind of the check for understanding area. I'm going to stop talking for a minute, pause my video, do these problems, do all 4, and then continue on with the presentation to get the answers. I'm back. 12 and 20 is 4. 18 and 22 is 2. 18 and 30 is 6. 25 and 5 is 25. So hopefully you guys got those. If you didn't, go back, watch the video, see if you can get them right. Well, the recap. Prime factors, there's a whole bunch of different ways. They actually say there's 3. There's a guess method too, but guessing, no, I don't think guessing is going to help you guys. But I can show you that too. But there's probably more out there. But these are how you do greatest common factors. Either A, you can write out all the factors and circle what they have in common. Or B, you can do the factor tree and circle what prime factors they have in common and then multiply them together. Your choice. Do either. Try both. See what works for you. If you're not understanding either, of course, tomorrow, say, Mr. Beuthin, I'm not getting any of these. Can you show me, help me? How can I understand this? Because I want to get an A in the next test. What can I do? And I'll show you. So the student will be able to find the greatest common factor. This will be done through a presentation and classroom activity, is what you just did in the activities tomorrow. Have a good day. This has only been a 7-minute and 35-second video, and we're done.